Okay, guys, in this video, what I'm going to do is I'm going to describe what this is, okay? This is question 1 from the 6th edition of the 100 and, what's it called? The Coding Interview 189 Problems. This is solution 1. I'm just going to describe them to you. This one's easy. The other one's a little bit harder, so I'll just explain how this works, okay? What's happening here is this. You're saying you're first going to check, all right, well, if the string length is greater than 128, you're going to have a repeat. Well, why is that? Well, you'll have every letter in the alphabet, right? More than once. So that'll be that. So what you do is you make a new character set that has 128 slots for Booleans. Now, where's that 128 come from? Well, if you look at ASCII, okay, the lowercase a is, let's see, our lowercase a is 61. We'll do uppercase a first. It's 65. So our uppercase a is 65, okay? And then it goes uppercase B is 66, so on and so forth, okay? And if we're looking here, our lowercase z, so it's going to go uppercase a to uppercase z, and then there's going to be some numbers in between. And our lowercase z is 122. Is 122. So this will allow us to basically store all the characters in here, right? You probably don't need all 128. You could do a couple less, but this will be fine. All right. All right, so how does this work? Well, we have an array that looks like this. All right. And each spot here, this spot is 0. This spot is 1. This spot is 2. This spot is 3. 4, ... 128. Okay. So that's how it's going to look. And let's look at what else is going on. So we have our char set. For int I is less than string.length I++. Great. Okay, so this is just going to go from 0 to however long our string is right here. So however long the string is. Val will equal string.char@I. So char@I gets the value, like, let's say our string is, I don't know. Let's say our string is equals, I don't know, person. Okay, with a capital P and a capital S, right? So if we look at our ASCII table, capital P is 80. The decimal equivalent of capital P is 80. So that means it's slot 80, somewhere like over here, say. We're going to put true. That's what this does. If char set at val equals, if it's true, return false. Okay? You're just going to return false. If it isn't, set char at, in this case, would be 80 to true. Okay? Fantastic. Let's do E. So lowercase e is 101. So now we have 101. Let's just say this is 101. Okay, this is going to be true. R is, let me just sort of redo this a little bit. Let's just modify this a bit so it's not confusing. Go like dot dot, and this was lowercase e was 101. Okay, so we'll say this right here is 101. We skipped whatever, how many, right? We'll put t. R, it's gonna be 114. So put like dot 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 dot, and then we have 114, and we get t. And then we get capital S. Capital S is 53, so let's just say dot, dot, dot. Let's just pretend this is 53. Put T. Let's just finish it off. Lowercase o is 111. Let's just say this right here. Again, we're skipping around 111. We'll put T. And N is 110. So let's just say it's T right there, okay? So just pretend that's 110. So we just set our arrays to true and false. Great. All right, fantastic. Well, how does this work? Let's say we use something a little different. Just to make my life easy, I'm going to use uppercases here. And we're going to do a repeat. You're going to see what's going to happen. We're actually going to do this with perfect value. So we're going to say this. We're going to say that this is 65. All right. By the way, the 122 will fit everything, right? From 0. There's going to be nothing in 0 and 1, right? So we have 65, 66, 67, 68, 69, and 70. We could do 71 too, why not? And we're going to come up with this string. Ready? Now our new string is going to be this. So we're going to get rid of this string. We're going to make a new string. We're going to call it A, B, C, D, B. Okay, so we're going to do this code. And we're going to say, and okay, great. So string.length is 1, 2, 3, 4, 5. Great. Okay, int val equals string.char_i. Okay, so A. A is 65, so we're going to put true. And we're going to look. If char set at val is char set at 65, is it true? So this is saying if char set 65 is true. Is it true? No. Okay. I mean, it wasn't. We're good now. Fantastic. If it isn't, set it. Actually, you're setting it there. Okay, then we'll go, okay, next char. B. Val is 66. Is 66 true? No. We'll make it true. Okay, good. Wonderful. Let's do the next value. We'll do 67. So the val is going to be 67. Is it true? No, we'll put true. Great. Let's do 68. Next iteration, we're going to get 68. So 68 is true. Just making sure D is 68. Yes, it is. And then we're going to check B. Now our value is going to go back to 66. It's going to say if char set at val is true. It is true. 66, it's here, it's true. You're going to return false. That means we found a duplicate. So there's just basically a long flag of these booleans figuring out whether or not we've seen the number. That one was pretty easy to understand. The next one is tricky, actually. I found it tricky. This one isn't too bad. So hopefully that makes sense to you. All right? Let's try the next one. The way this is working is you're making an int. Just so you know, the way it's going to work is assume all values are lowercase. And we have 26 bits. First of all, an integer equals 4 bytes, which is 32 bits. We actually don't need all those bits for the alphabet. We only need 26 bits. Where each bit, so let's just pretend we have a bit string here. This is going to be the most significant bit, so the least significant bit. So this will be A. So this bit is going to be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Okay, so this is bit 0. Well, actually, I'm going to say for here, just this is assuming it's all lowercase, by the way. We're going to put this is A, B, C, D, E, F, G, H, I, J, K, L, whoops, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Okay, I don't know how these people think of these algorithms. This is really smart. Okay, so what you're going to do, like for example, if you have an A, what this line is doing, you're getting a value. So let's get our value. Let's just pretend we put in C. So C minus A. If we look at our ASCII table, lowercase c is 99 minus A is 97. That equals 2. So that means index 2. This is index 0, index 1, index 2, index 3, dot, 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 to index 26. So in fact, yeah, awesome. Index 2 is C. Cool. All right. That makes sense. So we got the index. So we're going to say this is going to be the index. Now what the heck is this thing doing? This is tricky. I'm going to explain this step by step. We are going to do this part first. 1 bit shift val. What the heck? What does that even mean? Well, I have a 1. Okay, 1 is going to represent something. Now I'm going to shift it over by the val. So like for example, in this case, my val was we look 2. So I have this right now, okay? My bit string right now is going to look like this. I have 1. And then I shift it over 2 spots, so I get 1, 0, 0. Basically a bit shift means kick this over 2 bits, so it's going to put here, and fill the empty bits with zeros. Let me give you a quick example up here. 1, 0, 1. Left shift 1. So I'm just going to shift all the bits 1 over to the left. So this one is going to go over here. I'll put it in red. This one is going to go here. Okay. This one's going to go here. This one's going to go here. And then we have to put a 0 at the end. That's all it's doing. It's the same as multiplying by 2 actually. Because in binary this is 1, 2, 4. This is 5, this number. So 1, 0, 1 equals 5. And then 1, 0, 1, 0. This is 1, 2, 4, 8. So that's 8 plus 2 is 10. So by shifting over 1 bit, it's the same as doubling the value. That's not really necessary to know. But know that the reason why they're shifting 1 over the value, is to get to the place. So, for example, if I have C, it says checker, checkers, this bit string, is going to equal, let me explain what this does now. Checker is going to equal itself or the bit string. So it's going to OR it. Let me explain. Let's say checker is originally, it doesn't matter. Let's just say it's originally 0. And then I say OR, well, let's say we had C. So we said, all right, 1, remember C, we'll put it over here, 1 shift val when C, val was 2. So remember, we shifted over the 1 2 spots. So we get 1 0 0. And we look, that's 1 2. Great. C. Fantastic. Okay, wonderful. So what does OR mean? That's a little tricky. OR means this. 0 or 0 is 0. This is 0, 0. So we get 0 and 1. So OR does this. If I have a truth table, and I OR them, 0 or 0 is 0, 1 or 0 is 1, 0 or 1 is 1, 1 or 1 is 1. So it just basically adds it. Or you could think of OR as an adding. So I know that my bit string now, my checker, was 0, and now it's 1 0 0. Great. Fantastic. So I have this right now. Oops. All right. Let's do another letter. Let's do, that was C. Get rid of all this so it's not confusing. Let's do this word, C-A-T. So if we do A, so we're going to say A, this is 0, so val, I'll put val here, is going to equal 0, because A minus A is 0. This is all lowercase. Okay, 1, we're going to shift it over, well, val is 0, so we're not going to shift it over at all. It's going to stay where it is. Fine, all good and well. So it's just going to be 1, right? That's just going to be 1. Now, checker. Now, let me explain what this does. We're going to say checker is currently 1 0 0, all right? And our new value is just simply 1. It's 0 0 1. Okay? And now we're going to AND them. 0 and 1 is 0. 0 and 0 is 0. 1 and 0 is 0. So the AND truth table looks like this. 0 and 0 is 0. 0 and 1 is 0. 1 and 0 is 1, 0. And 1 and 1 is 1. Okay, that's how AND works. This is AND. So now we say, all right, well, it's not greater than 0. It's 0. So we're not going to return false. We're going to say checker now equals what the checker was. Okay, so let's look. What was the checker? The checker was 1 0 0. And then we're going to say OR. So we're going to say OR it with the val. OR it with 0 0 1. So 1 or 0 is 1, 0 0 0, 0 1 is 1. So now we have 1 0 1. So in other words, that tells us, if I look at this array, I have put in a C, and I've put in an A. Let's try a T. Let's do it with a T. All right, so let's do it with a T. Well, if we look at a T is 1/16 minus A, which is, I just Googled ASCII chart to get these values. 97, which is 19. So val is now 19. Okay, great. So we're going to say if checker and 1 shifted over 19 spots. So let's take 1 and shift it over 19 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Good, we got to T. That's 19 spots. So this will be 1. So if you were to, what do you call it, AND these, you're going to have 1 with 18 zeros and 1, 0, 1. So this is going to be 0. Remember, this is all 0, 0, 0, 0, 0. 0, 0. This will be 0 because the bottom number this here will be 0 for the bottom number. So that'll be 0 and everything will be 0. So it'll clear itself out. Great. That means we don't have a T yet. Awesome. All right. Wonderful. So then we're going to say, well, our new number is our new number plus the previous value. So that value was 1. Remember, we shifted the 1 over. Val times 19 times. 1 with, if we shift it over once, we get 1 0. So if we shift it over 19 times, we get 18 zeros. 1 with 18 zeros. So 1 with 18 zeros plus that. $15, $16, $17, 19 zeros rather. It's 19 zeros, my fault. Okay, so there you go. So that means I put in a T, I put in a C, and I put in an A. Wonderful. Let's look at a duplicate. Let's look what happens if we put in a C. C-A-T, C. Let's just see what happens if we put in a C. So C minus A is, so that's 99, it's 2. So the val is going to be 2 here. So let's look at checker. So we're going to take this huge value and we're going to put 2 underneath. So we're going to put, I'll put it above it. 0, 0, 0. Well, those are some really crooked numbers. 0. Let's try to get it close. 0, 0, 0. This is going to be 2. 0, 0, 0, 0, 0, 0, 0. 0, 0, 0. 1, 0, 0. Great. So when we AND these, this will even out to be 0. All of these will all be 0. Okay? All 0, 0, 0, 0. This is going to be 1. 1 and 1 is 1. This will be 0, and this is going to be 1. And what do we see here? Oh, sorry. That's wrong. This will be 0. Okay, that'll be 0. So what do we see here? We see that this value will not be 0. This value is going to be 2. This is 0. This is 1, 2, 4. The value will be 4, rather. So that means that this expression, checker and 1 shifted over the number of letters of C, is not greater than, is greater than 0. It actually equals 4. So you're going to return false. That means at this spot, you already flagged that bit for a letter. Hopefully that made sense. So basically what you could think of as this integer as 26 bits plus 7, 28, 29, 30, 31, 32. These are not even used. They're just leftover. You're not using them. And when you do this, you're saying take the 1 and shift it over the number of times of the letter. And then when you OR it, you're putting it in the spot. You're placing it in the spot. Then the next time you're saying, when you AND it, is there a bit in that spot already with the number I'm putting in? If there is, that means the number is going to be greater than 0. So hopefully that made sense and you enjoyed the video and you learned something about bitwise operators, the AND and OR operator, and binary. Thanks for watching.